Hello everyone. Welcome back to the session 4 of Statistics for Data Scientists. In this course, we are going to talk about the measure of central tendency. In the last session, we have talked about descriptive statistics and inferential statistics. In descriptive statistics, we have come across two different measures, that is measure of central tendency and measure of variability, where we have seen that these two measures are used for describing the entire data set, right? So, in the measure of central tendency is mainly focused about explanation of about describing the distribution of data. Okay. Now, it is also a statistical metric which is used to summarize the central or typical value of data set. Now, it also provides an insight into the central position or the average of the distribution of values. Okay, like how the values are distributed. So, with the help of the measure of central tendency, we can like identify what is the central distribution of our data set. Okay, now see, it is good to always start. It's not just good, but it has been suggested to always start your data from the average or from the middle of your data, or from the middle value of the new data set. See, when we have a very small data set which include 100 data points, so that is not a very tedious task to analyze it. Okay, we can even have a we can have a manual intervention, and we can examine the data, how the data is distributed. We can find the upper limit and lower limit. We can check the data. We can check the middle of that. We can check its distribution. But when the data is very enormous and huge, like when the values are in hundreds and thousands, so it has been preferred, and it is said to be good to start your data from the mid of your data point or from the average of your data. Okay, so now we will come on to the mean of the first measure in the measure of central tendency is mean. So mean is nothing but it is the average of the given set of the data. Okay, so basically the formula for mean is sorry, formula for mean is summation of all the data points by number of elements in that. Suppose let us take an example. We have data points with 10, 15, and 20 and 25. Okay, so the mean in this value will be summation of all these values: 10 plus 15, 25, 20, 45, 25, 45 plus 25. It is going to be 70, and number of data points we have 4. So it will become 17.5. 17 point, 17.5. Right. Now one thing over here, you can see that the lower limit, the range of this data point, the lower value we have over here is 10, and the upper value over here is 25, and the mean value that we are getting over here is the average. That means that the mean value will lie somewhere in between the lower point and the lower value and the upper value. Okay. Now one important point over here is the mean is very sensitive to outliers. Okay, now suppose let us take the same example, but we will include one more point. Okay, suppose we have 10, 15, 20, 25, and let us take one more element as 120. Now in this case, 70 plus 120 will be 190, and then we have 5. Okay, sorry, 6. This time it will be 6. I'm sorry, that's fine. 3 to 5, yeah. And then 15, then 4, 38. The average value will be 38. Not just, you can see over here is that out of these out of these 5 data points, 10, 15, 20, 25, these 4 data point does have a standard deviation of 5, and the last one, which doesn't appear to have this standard deviation of y, it has a very huge standard deviation from the rest of these elements. Now this will behave as a outlier, right? And in you can see that how it has impacted the mean value, right? So it is not going to be a normally distributed data. There will be an skewness in our data, right? It will be something look like, okay, it might be skewed towards the right of the data. So it is sensitive to data set. Now there is one more example. It's better. Okay, suppose we have data points. Okay, and it's a group data point, right? Xi, and we have uh, just a moment. Let me just clear it. Okay, so there is a 20 to 10 to 20, sorry, and then 20 to 30, and then 30 to 40, 40 to 50. Okay, and the corresponding frequency value we have, and that is 2, 3, 3, 4. Okay, and so what I mentioned you, we need to calculate the midpoint of the group value, okay, or the interval value. So this will become, so 20 and 20 30, it will become 15, and then 50, it will become 25, and then we have 70, so this will become 35, and 90, so this will become 45. Now we have to calculate the xi, we have to calculate fi into xi. So basically the formula for group mean is that, okay, it is nothing but xi into fi by by the frequency assumption, right? Or mention it, sorry. xi. Okay, so the value will become 30, and then 25, 105, and then 180. Okay, so here this will become 12, and this will become so 105, 105, 2 to 10, and then this will become 390. So the formula for the group mean value will be, okay, 390 by 12. Something, I think 5 or something. Okay, so this is how we are going to calculate this group mean. Now again we have another concept called weighted mean. Okay, now what happened in weighted mean is used when each data point has a different weight or importance associated with it, right? When we have different weights associated with every data points. Like just let's take an example. Basically in a school we used to have three or four exams for students under 10. Okay, suppose in a school we have four exam, exam 1, exam, okay, exam 2, and then we have exam 3, and then we have exam 4. Okay, so suppose suppose one of the students he scored 40 in exam 1, 60 in exam 2, 80 in exam 3, and 90 in exam 4. Okay, now what will happen? So on an average, we can calculate, we can just sum it and we can divide it by 4, we will get an average. But what will happen? Okay, what will happen when, like, when there will be a category, okay, of exam 1, exam 1, exam, exam 2, and then assignments, and then we have practical, and then we have midterm. Okay, and there will be some weights assigned to each of these. Okay, weights like 30% from exam 1 will be considered, 30% from exam 2 will be considered, and practicals we will consider 15%. Sorry, assignments we will consider 15%, and practical we will also consider 15%, and midterm we will take 10%. See, in this way we are just covering the entire 100%. Okay, and so now we have to calculate the weighted mean in this case. Okay, this is what I mentioned, that in case if we have a we have some we have a like a weight assigned for each category. Okay, okay, or each data point. Okay, when there will be a different weight for each data point, in that case, how are we going to calculate it? Okay, so 30% means 0.3. Okay, and this is also 0.3, and this will become 0.15, and this will become 0.15, like, and this is 0.1. Yeah, I'm just now basically, so the formula for the weighted mean is becomes the weighted mean W1 x1 plus W2 x2 until Wn xn by all the weights, W1 plus W2 plus until Wn. So in this case, okay, so Wi into Xi, how are we going to get it? So 30%. So it's okay, we have not mentioned. Just a moment. Let me just drop it. So it becomes shabby. So score we have not given. Suppose this score, I'm not habituated of using this pen type. Suppose exam one we have 90. Okay, exam two we have got 80, and in assignments we got 85. In practicals we got something 95, and then again we have 85. Now the percentile value weighted score, okay, weighted score will be something like 27, 30% is 27, then 30% is 24, and then we have 15% 12.75, then we have 14.25, and 10% of 85 is just 8.51, right? So this will become 86.5. Now that what I mentioned, it is the product of Wi into xi, weight and the data points by all the weight. Now see, weight in this case it will become 0.3, 0.3. Finally, it is going to become 1. So it is 6.5 by 1. So the weighted gain is, it is 6.5. Right. Now let us firstly cover mean and mode. Okay, so we are little behind. So median. So median is basically median is nothing but it is the central. It is the basically it is the mid value of a, when suppose, let me give you an example. Basically, the median is the middle value of a data set. Okay, and it is the middle value when we arrange it in ascending or descending order. Okay, first we have to order it either in the ascending or the descending pattern, and then the middle value will be the median. Now the question arises here: what will happen when we have odd number of data points and even number of data points? Okay, suppose when you have odd number of data points, so the odd number of data points, so easily we have this. I'm sorry. So suppose in this case we have odd number of data points. Okay, we have five data points. In this case, three will become, 3 is nothing but the it is the median, right? And like in case when we have one more data point, suppose six, suppose six would have been there. So, 1, 2, 3, 4, 5, 6. Okay, now we have six data point. In this case, how are we going to find the median value? Okay, so what we'll do that, we will take the average of these two values. Okay, and this will become 3.5. So this will become the median, right? And when we have odd number of data points, like 1, 2, 3, 4, and 5, we have five number of data points. This will become the median, right? Now, what is mode? Mode is nothing but the most frequently appeared data point in our data set. Suppose 1, 2. 3, 3, 5, 6. So 3 is the mode of. Okay. Now one more thing, when we have multiple values, okay, when we have multiple values within a data, like suppose in this case, 1, 2, 3, 3, 5, 4, 6, 6, 7. Okay, in this case the mode will be 2, and again the mode will be 6. So we will be having two modes, 2 and 6. Okay, so the mode is the most appeared value within the data set. That is the most. Okay, and mode is suitable for nominal and ordinal data, which we have already discussed on nominal and ordinal data, where the ordinal data, which does have, along with the labels, which does have direction as well. Like the example of, suppose when we have salary, okay, when we have this labeled salary, high, medium, and low. Okay, so that is an example of ordinal value and nominal value. Okay, which does have label but doesn't have any order. Okay, like gender, male and female, we cannot order it, right? Yeah. So in some cases, a data set may have no mode if all values occur with equal frequency. That's true. Okay. When the number of frequencies are same, in that case, we don't have any mode value. So this is all about the central tendency. In case if you have any question, please comment in the comment box and share your problem with me. Okay, we'll try to sort it out.